Our goal is to convert a measurement in grams to a combined measurement of pounds and ounces. In order to start this process, we need to think through what we have memorized. I'm going to go through the process using 3 different methods. You can click on the button along the top of your screen to go directly to the method that you prefer. We'll start with dimensional analysis. In dimensional analysis, I start with the given information, 3,267 grams, and I place that over 1. The 1 is simply a placeholder for the dimensional analysis strategy. My first conversion is to change grams to kilograms because I have memorized a kilogram to pound conversion. So I know that there are 1,000 grams to 1 kilogram. I put the grams on the bottom of my fraction to cancel that label, and the kilograms on the top of my fraction. As I mentioned, I have memorized that 1 kilogram is 2.2 pounds, and so I use that as my next conversion. And again, I place the kilograms so that the label of kilograms will cancel. I realize that I want a label of pounds and ounces. At this point, I'm at a label of pounds. I need to calculate this number before I can go to ounces because I only use ounces for the partial pounds. Going to my calculator, I have 3,267 times 2.2 divided by 1,000. And that gives an answer of 7.1874, and that answer is in pounds. In the American system, we will give the pounds as the whole number. So I have the answer to the first blank. We'll convert the partial pounds, the decimal amount, into ounces. And that's why I needed to calculate the pounds before I could move to calculating the ounces. So I'll take just the decimal part, the 0.1874, and that has the label of pounds. Again, doing dimensional analysis, I place it over 1. And my conversion is that I know 1 pound, put that in the denominator, is the same as 16 ounces. The label of pounds cancels, and I'm ready to do the calculation. On my calculator, I have my previous answer. I'll subtract the whole number from that because I've already used that. That gives me the whole decimal without any rounding. I multiply that times 16, and I have my answer. Typically, we will round this answer to the nearest tenth. When I do that with this particular answer, it turns out to be a whole number. So it would be 3.0, and we'll simply write 3 ounces. Our next method is to use the proportion approach. In the proportion approach, we'll start by using our metric line to convert the grams to kilograms. Our metric line can be memorized by using King Henry died by drinking chocolate milk full of microorganisms. The grams is a base unit here in the center of the metric line. My goal is to go to kilograms because I know a conversion from kilograms to pounds. So I'll need to move my decimal 1, 2, 3 places. In the number given, the decimal is at the end of the number, and moving 3 places in the same direction as on my metric line gives me a value of 3.267 kilograms. In a proportion, I'll put that over X with the label that I'd like to convert it to, and my first conversion is to pounds. On the other side of my proportion, I'll put my memorized information. I know that 1 kilogram is equal to 2.2 pounds. I put the labels in the similar locations. So on both fractions, kilogram is on the top of the fraction, pound on the bottom of the fraction. In a proportion, I'm saying the two fractions are equal. The only way for them to be equal is if their labels are similarly located. In order to solve the proportion, I multiply on the diagonals. This is referred to as the cross product because it makes an X in the center. On my first diagonal, I get 1 times X, which is simply X. On the second diagonal, I'll multiply the 3.267 times 2.2. So going to my calculator, 3.267 times 2.2. This gives an answer in pounds. At this point I know that X equals 7.1874 pounds. In the American system, where we have a mixed measurement, the whole number will be part of our answer. So I'll fill in the 7 as the number of pounds. The decimal part of this answer is what we will convert to ounces. So I'll start another proportion with 0.1874, and that is pounds. And I'll put that over X ounces because I wish to convert the fractional part of the pounds into ounces. On the other side of the fraction, I put my memorized conversion. I know that 1 pound is the same as 16 ounces. And again, I will solve this by cross product. So I'll multiply on the 2 diagonals. On the first diagonal, I get X. On the second diagonal, I'll go to my calculator and multiply the decimal times 16. On my calculator, I'll subtract 7 to get to the decimal. This is a nice strategy if you have a long decimal. You don't have to retype it. And then I'll multiply that times 16 as my work indicates. Typically this answer would be rounded to the nearest tenth. When I look to round to the nearest tenth, the 9 would round this 9 to a 10, which we'd write a 0 and put this as 3. We do not write trailing zeros in the medical profession, and so we'll give an answer of simply 3 ounces. Finally, we'll solve the problem using the nursing formula. In the nursing formula, we'll start our problem by using the metric line to convert grams to kilograms because we know a kilogram to pound conversion. So on our metric line, we have King Henry died by drinking chocolate milk full of microorganisms. Grams does not have a prefix, so it is a base unit. We want to go to kilograms, and so we'll need to move our decimal 1, 2, 3 places in this direction. Currently our grams is a whole number, so the decimal is at the end, and we'll move it 1, 2, 3 places in the same direction as on our metric line. This gives us an answer of 3.267 kilograms. The nursing formula is to take the desired amount, divide it by what we have, and multiply by the quantity that is. When we're working with the nursing formula, the measurements from desired and have must match and cancel. My desire is to convert this weight in kilograms into pounds. My desired is labeled in kilograms, so what I have must also be labeled in kilograms, and I know 1 kilogram is the same quantity as 2.2 pounds. When I set this up, the label of kilograms cancels, and I do the multiplication to get an answer in pounds. So 3.267 times 2.2 gives an answer of 7.1874 pounds. The label in my answer is always the label of the quantity, the label that did not cancel. When we're going to a 2-part label, the whole number is the first part, so this is 7 pounds. We'll then convert the decimal or the fractional part of the pounds into a different label of ounces. So our desire is to convert 0.1874 pounds. Since our desire has a label of pounds, we need to use a have with a label of pounds. So I have 1 pound, and that is the same quantity as 16 ounces. The label of pounds will cancel, and I'm ready to do the math. I go back to my calculator. I have my previous answer on the calculator, and I will subtract the 7 so that I have just the decimal. This is very helpful when it is a long decimal because it saves you from retyping. I'll multiply that by 16 and see my answer in ounces. Typically, ounces are rounded to the nearest tenth. When I round to the nearest tenth, I actually get a whole number, and so the value here is 3 ounces. In each different method, we had to do 2 steps to the problem because our answer has 2 separate labels in it.